Okay, 4, transformations of sine and cosine functions. So we've talked about the parent functions, the parent function for sine and cosine, and now we're going to look at doing some transformations where we do some vertical compressions and stretches, horizontal compressions and stretches, and then we do some shifting both vertically and horizontally. So first of all, any transformation, just so we know terminology, any transformation of a sine function is called a sinusoid. It's a spinoff of the sine or the cosine parent function. So general forms of these sinusoidal functions for sine and cosine are the following. So we have a lot of stuff that's been added to these. So we have a sine of bx minus c plus d for the sine function, and a cosine of bx minus c plus d for the cosine function. So one of the ways that we look at this as we start to look at these transformations, one of the ways that you also might see this written in other places may be a times the sine of b times x minus c over b plus d. In some textbooks or some videos, and some teachers like to always factor the b out, and that way you just have the straight x minus c over b, which we're going to learn is the horizontal shift inside the parentheses. And so likewise, they would use y equals a times the cosine, factor out the b, even though it's not a greatest common factor, and then it would be x minus c over b plus d. And again, this just kind of shows you the exact horizontal shift. And then b would be which is going to be affecting the period of these graphs, or the horizontal compression or stretch. Okay, so let's start off with some vocabulary. Some of it's going to change and some of it's going to stay the same. So you already know how to transform parent functions with trig, but some of the terminology changes. The transformations that are the same are going to be the vertical shift and reflections in the x and y axis. That terminology stays the same. But transformations that have some new terminology will be vertical compression and expansion. We're now going to call that the amplitude of the sine and cosine curve. And as we talked about earlier in the section or in the chapter, we know that amplitude would be from the midline to the top and the midline to the bottom, just that halfway distance between the top and the bottom. Okay. Then we know horizontal compression and expansion is something that we've done where we make a function wider or more narrow. That's now going to be called the period. So the period will be how long it will take the function to complete one full cycle. So if we look at the graph to the right, for example, if we look at it as a sine graph, we start at the origin, and this would be one complete cycle before it repeats again. And so the period will be how long it takes to complete one cycle. The horizontal shift is now going to be referred to as a phase shift. And again, if you look at the diagram on the right, a phase shift is where you have the point shifted, how far we shift until it's the same point in the other graph. Okay, one more term that's going to be fairly new, but should make sense, would be something called the midline. After you have a vertical shift, you're going to have a new horizontal axis known as the midline. This is the reference line or equilibrium point about which the graph oscillates. So for example, if a sine graph is shifted up 1, the new midline would be y equals 1. Just as we look at this graph on the right, the middle of the graph is the x-axis. So when we have a vertical shift, that midline will shift as well, up or down. So now let's take these functions and identify the certain variables that go with the definitions and with the terminology. So here again, we have the graphs of the sinusoid, a sine of bx minus c plus d, and y equals a cosine of bx minus c plus d. So the amplitude is going to be a. Just like amplitude, or just like the a value affects how wide or narrow a function is, it's going to do the same thing with sine and cosine and trig graphs in general. Amplitude is actually going to represent a distance So you may see the absolute value of A. When A is negative, we know that that deals with a reflection. So maybe we would write that over here. A negative A represents a reflection in the x-axis. So as we look at A affecting amplitude, we simply look at the positive. The period has a formula. Typically for sine and cosine, it takes 2 pi radians to complete one cycle. So if we change that, we're going to do 2 pi divided by b. And a lot of times as well, you may see the absolute value of b. So 2 pi over b would be the new period. And the frequency is simply the reciprocal of the period, so b over 2 pi. The phase shift. So as we look at the phase shift, back up here where I rewrote those formulas, this is one reason that people like to factor out the b, because then you can just see in the parentheses x minus, and then you'll have your phase shift, c over b. And also you can see those two written that way down here. Now, if you don't factor out the b, you're just going to have to remember to take the coefficient of x and divide it by c. It would still be c over b. The vertical shift will be our d value, what we add and subtract to the whole function itself, and that will also, as we said, affect the midline. So being a line, we would say that the midline is y equals d. Okay. So now we're going to put these into practice, and we're going to start with some little ones before we get into ones that get a little more complicated. So first let's think about how the graphs in example 1 of f of x equaling sine of x and g of x equaling 1/4 of the sine of x are related. Then we're going to find the amplitude and then sketch 2 periods of both functions, or 2 cycles, on the same coordinate axis. So if I have the sine of x and 1/4 sine of x, g of x is actually going to get more shorter, I guess, more shorter. It's going to get shorter. So the height or the amplitude will be 1/4 of the amplitude of the sine of x. So g of x, we could describe it as being vertically compressed by a factor of 1/4. So then the amplitude of g of x would be the a value, and the number that is in the position of the a variable is 1/4. Okay, now we're going to sketch the graphs of both sine of x and 1/4 sine of x on the same graph. So as we do this, you need to think about what your amplitudes are going to do, because you want to leave plenty of room. And we want to use a good amount of space to see a good graph. So when I have an amplitude of 1 in my sine of x function and 1/4 in my other sine of x function, I'm actually going to divide my scale vertically into fourths. So I'm going to go up 4 before I label a 1, and I'm going to go down 4 before I label a -1. Now, I'm not doing any changes with the period or any vertical shifting. So I'm actually going to, but I need to consider that I need 2 periods. So 2 full cycles of the sine curve. So with this one, I actually used a scale of 1/4. And you're not going to do this every time. You just kind of have to think about it and play with it. And sometimes you'll label your axes and you'll run out of room, or it will be too short and you'll want to erase and start all over again. It just takes some practice. So my scale is 1/4, which means that every tick mark horizontally represents 45 degrees, or pi over 4. But I actually am going to label every other one. Actually, I'm going to make this a little bit smaller maybe, so I can, so pi over 4, and then 2 pi over 4 is pi over 2. 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, which is 3 pi over 2, 7 pi over 4, 8 pi over 4, which is 2 pi. So that's going to be one cycle, but I'm going to keep going again. So 9 pi over 4, 10 pi over 4, which is going to be 5 pi over 2, 11 pi over 4, 12 pi over 4, or 3 pi, 13 pi over 4, 14 pi over 4, or 7 pi over 2, 15 pi over 4, 16 pi over 4, which is 4 pi. And that will take me through 2 cycles. So if that was kind of confusing to you, you may want to go back, watch that part again as to how I counted them, because I did reduce them as I wrote them down. Now, if you want to write them all in pi over 4s, that is actually okay with me. I want your graphs to be correct, so if you want to write them without reducing, I would like for you not to, but I'm okay with that if that helps you. Okay, so now let's graph this. So with the sine function, we know that sine starts at 0, 0. It ends at 2 pi 0. In the middle, it's 0. Pi over 2, it's at 1. And 3 pi over 2, it's at -1. So this is just the parent function. So again, we should be okay with graphing this at this point. Just the parent function. Make sure it's curved. And then we're going to go again. So those 5 key points for each cycle are always what you want. And I kind of do my own thing by 0 at the beginning. It's where it is at the beginning, where it is at the end. Then I mark the middle. And then I divide the other halves and mark those. Now, if you watch the guy in the video, he does it in order. Either way is okay, of course. All right, now for the g of x. G of x is, sorry about that. So g of x is 1/4 of the sine of x. So the only thing that's going to change is my amplitude. So instead of going up to 1, we're only going to go to 1/4, which actually is going to be right here. So I'm going to start at 0, end at 0, the middle is at 0, but I'm only going to go up to 1/4 and down to -1/4. There's one cycle of 1/4 sine of x. Then the second cycle, I start at 0, end at 0, the middle's at 0, right? Amplitude of 1/4 will not affect the x-intercepts. So then when it's at 1, it's now at 1/4, and when it was at -1, it's at -1/4. Okay, and there is my 1/4 sine of x and sine of x. Good. Okay. Next one. Describe how the graphs of f of x equaling cosine of x and g of x equaling -3 cosine of x are related. Then find the amplitude of g of x, sketch 2 periods of both functions on the same coordinate axis. So the -3 is actually going to reflect over the x-axis. It will reflect the cosine graph over the x-axis. And the 3 will vertically stretch g of x by a factor of 3. Okay, so the amplitude of g of x is just 3. Remember, amplitude is an absolute value. It is a distance. So now we're going to graph this. So here's what we have to think about now. One of my amplitudes is 1 and the other one is 3. So I definitely can't do I can't go in fourths vertically. So I'm actually going to go every other one and label it 1, 2, and 3. I mean, that's positive. Okay. And then -1, -2, and -3. So the period's not going to change again, so we can label horizontally the exact same way. So again, I'm going to use a scale of pi over 4. So here we go again. Try to do this with me. 1 pi over 4, 2 pi over 4 is pi over 2, 3 pi over 4, 4 pi over 4 is pi, 5 pi over 4, 6 pi over 4 is 3 pi over 2, 7 pi over 4, 8 pi over 4 is 2 pi. There's one cycle. We have to do it again. So we're going to keep going. Now, Ms. McDaniel, could I just rewrite pi over 2, pi, 3 pi over 2, and 2 pi? You really can't. That's just not correct. It would kind of be like when you label the x and y coordinates going 1, 2, 3, 4, 5, and then going 1, 2, 3, 4, 5 again, which we know is not true. It goes on to 6, 7, 8, 9, 10. So we really do have to keep going and counting up. So 9 pi over 4, 10 pi over 4 gives me 5 pi over 2, 11 pi over 4, 12 pi over 4 is 3 pi, 13 pi over 4, 14 pi over 4 is 7 pi over 2, 15 pi over 4, 16 pi over 4 is 4 pi. So there are my two cycles. All right, now let's graph the parent function for cosine, and we really, at this point, have to know what it does. Cosine starts at 1, it ends at 1. In the middle, it's at -1. And then halfway between the first and second half, they both have their intercepts. So here is a cosine graph, and please make sure that you're curving them, right? Should not look like a V. And then again, from 2 pi to 4 pi, another cycle. So it starts at 1, ends at 1, in the middle it's at -1, and then halfway in between there are my intercepts. Okay, so there's the parent function for cosine. Now let's do -3 cosine of x. So we have two things going on. We have a reflection in the x-axis, and we have a vertical stretch by a factor of 3. So we were originally at 1. When we reflect, we'd be at -1, and then a vertical stretch of 3 would put me at -3. So now we think about the cosine graph being flipped over and stretched. If I start at -3, cosine would end at -3. In the middle, it would be up at +3. And then, of course, reflecting over those intercepts doesn't change a thing. So this would be one cycle of the cosine graph. And then we would go again. At 2 pi, it starts at -3. At 4 pi, it ends at -3. Halfway at 3 pi, it's up at +3. And then those intercepts, halfway marks, are still the same. So there's the second cycle for the cosine graph. And there is the cosine of x and -3 cosine of x. Hope that makes sense so far. Okay, now we're going to deal with some period changes and phase shifts. So when a transformation has a period change, and again, as a reminder, the period for a normal sine and cosine curve takes 2 pi, and or a phase shift, again, they start at 0 and they end at 2 pi. So we're going to shift that. It's helpful to identify, like we just said, the starting and ending values, which we just did. And now, to see what our phase shift is going to be, we're going to actually do this. We're going to set the 0 and the 2 pi equal to our new bx minus c, because that's what's affecting our start and our finish. So for the sine and cosine functions, we start at 0 and 2 pi, but this will now give us a new start and finish for our x values in the transformation. After we figure that out, we're going to apply reflections, any vertical expansions or compressions, and vertical shifts. Okay, so let's see how this is going to be related. And this first one actually is just going to have a period change, not a phase shift. So describe how the graphs of the cosine of x and g of x equaling x over 3, which that is the cosine of 1/3 x, are related. Then we're going to find the period of g of x, because the amplitude hasn't changed, but the period will change. We're going to sketch at least one period of both functions and the coordinate axes. So as we look at this, the 1/3 of x, that is what we would recognize as being a horizontal compression or expansion. And this is actually going to be horizontally expanded by a factor of 1/3. So g of x is horizontally expanded by a factor of 1/3. So the period of g of x now, remember period, the formula is 2 pi normally over 1 with the parent function, but our b value is 1/3 because period is 2 pi over b. So if I take 2 pi and divide it by 1/3, remember that's the same as 2 pi times 3 over 1, so the period is 6 pi. So it is now going to take 3 times as long to complete one cycle. So keeping that in mind, this is probably why we just have to sketch one period, because it's going to be 3 times as long as the parent function. All right, so now as we think about our scale and how we're going to label this, I'm actually going to do up 3 and down 3 for my vertical. No rhyme or reason, just that I can. Just kind of mixing it up and trying to help you understand that you don't always have to do the same thing, but you have to clearly label. So my scale for this one, because I have to make it to 6 pi, I'm actually going to go by pi over 2. So every tick mark will be pi over 2, but I'm only going to label, again, every other one. And I just need to label one cycle, and that needs to go all the way out to 6 pi for g of x. So pi over 2, 2 pi over 2 is pi, 3 pi over 2, 4 pi over 2 is 2 pi, 5 pi over 2, 6 pi over 2 is 3 pi, 7 pi over 2, 8 pi over 2 is 4 pi, 9 pi over 2, 10 pi over 2, 11 pi over 2, 12 pi over 2. So look how neat that was. Pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi. Okay, so now to do cosine. Cosine only takes from 0 to 2 pi. So let's draw one cycle of the cosine function. It starts at 1. It ends at 1. In the middle, it's at -1. And then halfway between each of those halves, it's an intercept. And there is the cosine function, just cosine of x. Okay, now we're going to do the cosine of 1/3 x, or the cosine of x over 3. One cycle is 6 pi. So it's going to start at 1. It's going to end at 1. Halfway would be 3 pi, and it would be down at -1. Now halfway between 0 and 3 pi is not 2 pi. So you could actually count tick marks. You would count 1, 2, 3, 4, 5, 6. So there are 6 tick marks between, so halfway would be 3. So right here, actually let me take those off of there. So right here would be the middle, and then I would count 3 up from 3 pi, 3 lines up from 3 pi, 1, 2, 3, right there. And there's my cosine graph, or the cosine of x over 3. Okay. All right, so now we're going to do an application problem that really doesn't have anything to do with graphing, but we're going to bring the frequency. We tend to forget and not use frequency too much, but we're going to use frequency for this one to help us solve this problem. So it says musical notes are classified by frequency, and some of you may already know that. In the equal tempered scale, middle C has a frequency of 262 hertz. So that's important information. Hertz are oscillations per 1 second. Use this information to write an equation for a sine function that can be used to model the initial behavior of the sound wave associated with middle C, having an amplitude of 0.2, and using the general form of the equation y equals a sine of bt. So essentially, what we have to do is find values for a and b. Well, I know that in y equals a sine of bt, a is the amplitude, and they tell me the amplitude is 0.2 or 2/10. I know that b has to do with the period, so if I don't know the period, but what I do know is the frequency, 262, is equal to, the formula is b over 2 pi. So as I multiply across, like a proportion, if I put 262 over 1, b is equal to 524 pi. So I'm going to put this all together in my equation. Y equals, my amplitude is 0.2 times the sine of 524 pi times t. And as quickly as that, we have our answer. So they want an equation in that general form describing, apparently, the sound wave for middle C. Okay, a few more examples, and they are going to get a little tougher. But again, there is a very systematic way to do this. So at this point in time, you don't have to, but I would highly suggest that you would go to the other videos on Canvas. There's the 3 other videos with the guy Zach that we've watched before. Pick up where we left off and watch how he transforms the sine and cosine curves. This is the method that I'm going to use. It is called the box method, and he does a great job of explaining the box method. So I would really suggest that you go watch the video and watch him do a function. I can't remember which one it is. I think it's 3 minus 2 sine of x or something like that. And just watch it for a couple of minutes and then come back and try this with me. But it's completely up to you. Okay, so we have y equaling the sine of 3x minus pi over 2. We want to know the amplitude, period, frequency, and phase shift. Then we're going to graph 2 periods of this function. So I'm going to hope that you've watched the video because I'm going to use some of the terminologies that he uses, and it's how I taught it in class. So he writes out his characteristics of the equation he's looking at before he starts the graph. So vertical translation, amplitude, phase shift, and period. So he uses the acronym of VAP, V-A-P-P. And those are going to give us the things that we're actually looking for. So vertical translation, if we look at this, there is no D value. So there is no vertical translation. We don't have to worry about that. The amplitude is going to be 1. Now, the phase shift. If we look at the phase shift, this is our C value and pi over 2, and 3 is our B value. So to find the phase shift, we could absolutely do pi over 2 and then divide that by 3, which pi over 2 divided by 3 is the same as times 1/3. So my phase shift would be pi over 6, and because it's minus, it would be to the right. Now, that's how you can just give somebody the phase shift, pi over 6 to the right. But here's what I tend to do every single time I graph these. This is part of the box method. We want to create a rectangle so that we have one wave of the sine graph to draw within this rectangle and to fill it out evenly. So when it comes to the phase shift, just like we talked about before, we're going to think about where sine normally starts. Well, the old start for sine is 0. And the old, I guess I should say original, but the old finish is 2 pi. But we have some things going on. We have 3x minus pi over 2. So I'm going to take that 3x minus pi over 2 and set it to the original start for sine. And I'm going to also set it to the original finish for sine. And I'm going to solve these for x. So for the old start of 0, when I solve for x, I'm going to get the new start. So I'm going to add pi over 2, and 3x is equal to pi over 2, divide by 3, or multiply by 1/3, and x is pi over 6. And that's exactly where we saw our phase shift. Pi over 6 is pi over 6 radians to the right of 0. But what I like even better, so when we do our box, this will be the left side of my box, where it's going to start now. This is my new start. The old finish was at 2 pi. Well, now I'm going to solve this and see where my new finish will be. So add 2 pi over 2, add pi over 2. So 3x equals, now 2 pi, hopefully we can see that that's the same as 4 pi over 2. And when I add that to pi over 2, I get 5 pi over 2. And if I divide that by 3, which is multiplying by 1/3, I get 5 pi over 6. And this is going to be the right side of my box. And this is going to be my new finish line, or my new finish for the sine function. So now, before we do the period, which is going to be 2 pi over b, I want to just look, and common sense, look, pi over 6 to 5 pi over 6. It should start at pi over 6 and finish at 5 pi over 6. The difference between those is 4 pi over 6. And I can reduce that to 2 pi over 3. Okay, so this should be the period, because that should be how long it takes to complete one cycle. So when I find the period, I am more or less confirming the left and right side of my box, that it is the same. So I have 2 pi over b as the formula for period, and in my equation, b is 3. So 2 pi over b, or 3, is the period. So I have my amplitude of 1, the period, 2 pi over 3. Now, they also really quickly ask for frequency. That's the reciprocal of the period, so that's 3 over 2 pi. Check, did that. And the phase shift is pi over 6 units to the right. So now we're going to graph 2 periods of this. So amplitude is 1. I'm going to go back and I'm going to go up 4 and down 4 for my amplitude of 1 and -1. And so my phase shift, I have to be 1 pi over 6 to the right. So to make this easy on myself, that's going to be my scale. I am going to count by pi over 6's, which we know is 30 degrees. Okay, so as I label my scale, I am going to actually mark the first one, pi over 6, then 2 pi over 6. 3 pi over 6 is pi over 2, 4 pi over 6, 5 pi over 6. Now there's one cycle from pi over 6 to 5 pi over 6. So I'm going to go again. I'm going to label this one more time because I know I have to do 2 cycles. So 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6. And I can stop there. That would actually be 3 pi over 2, but I want you to look real quick. From pi over 6 to 5 pi over 6, that's 4 pi over 6. And 5 pi over 6 to 9 pi over 6, that's another 4 pi over 6. So hopefully the counting is making sense and the labeling is getting a little better. And again, we could relabel this as 3 pi over 2. Okay, so where does the box method come in? So now that we have things labeled, here's how we draw the graph. So we don't have any vertical translations. So my midline, we're going to draw a dotted line right through the middle, which is still, since we don't have a vertical shift, it's still the x-axis. My amplitude is 1, so above the midline, I'm going to go up 1 unit, and that will be the top of my box. And then I'm going to go down 1 unit below my midline, and that will be the bottom of my box. Now the left and right side, remember, the left side of my box was my phase shift. We're going to start at pi over 6, and we're going to finish one cycle at 5 pi over 6. So what I have, and you don't need to draw this, but this, just kind of watch, this is where I want to complete one cycle within that rectangle. So I just need to remember what I know about sine, and we'll do the graph. So I know that sine starts in the middle, ends in the middle, which is 0 and 0, pi over 2, and it's back in the middle on the midline. Halfway in the first part, it's up at 1. Halfway of the second part, it's at -1. And here is one cycle for the sine curve. And then we go again. We know that it's supposed to end again out here, and this could repeat on and on and on. But we're going to draw one more. Actually, I think it was this one. So it starts at the midline, ends at the midline. In the middle, it's at the midline. Halfway in the beginning, it's at the top, and halfway through the second part, it's at the bottom. And there's two cycles of the sine graph. So hopefully that makes sense, and each of those steps were logical for you. Okay, two more examples. So example 6, state the amplitude, period, frequency, phase shift, and vertical shift of y equals sine of x plus pi and then plus 1. And we need to actually graph two periods of this function. So we're going to start with VAP, vertical translation, amplitude, phase shift, period. And we're going to just list our characteristics. So vertical shift is 1, that's our d value. Amplitude, there is nothing in front of sine, it's just a 1. So amplitude is 1. Now our phase shift, if you look at this, you can straight away see that that's going to be pi units to the left. So just to label phase shift, that would be pi left. But what I'm going to do is I'm going to look at x plus pi and set it equal to where sine originally starts at 0. And I'm also going to set it equal to where sine originally ends, 2 pi. And I'm going to solve for x in each. So I subtract pi. So x is negative pi, and x is just pi. Actually, let me do a little more work on that so it's all even. Okay, so if we look, this is my new start and my new ending or finish. And logically, think about the distance from negative pi to pi. That is 2 pi. And that should be the period. But let's confirm that. So period is 2 pi over b, and b has a value of 1, so 2 pi over 1 is just a period of 2 pi. And then the frequency, which they asked for, is the reciprocal of 2 pi over 1, so it would be 1 over 2 pi. So we have our vertical shift of 1, phase shift of pi units left, frequency is 1 over 2 pi, the period is 2 pi, and the amplitude is 1. Okay, great. Let's draw this. Take it one step at a time. I'm going to go up 4 units and do 1, down 4 units, and there's my negative 1. Now I actually have to start to the left, pi radians. So to go back to the left, pi radians, I'm actually going to count. With this one, I used a scale of, oh gosh, I guess it was pi over 2 again. So I have to count backwards though, so I'm going to go back every other, no, I didn't either. I used a scale of pi over 4. Sorry about that. So let's rewrite this. I used a scale of pi over 4. So when I go back, negative pi over 4, negative 2 pi over 4, or negative pi over 2, negative 3 pi over 4, negative 4 pi over 4, which is negative pi. And then the other way, from 0 to the right, pi over 4, 2 pi over 4, which is pi over 2, 3 pi over 4, 4 pi over 4, which is just pi. So now we can label and draw that box. So we have a vertical shift or a vertical translation of 1. So I'm going to go up to 1 and draw my new midline. So my old midline was at the x-axis, now it's moved up 1. My amplitude is 1, so I'm going to go up to 1 and draw the top of my box, or an imaginary line for the top of my box, and down at the x-axis, down 1, and that would be the bottom of my imaginary box. Okay, so keep in mind, these dotted lines are not part of the graph. They're simply guidelines to help us draw the sine and cosine curves. Okay, the left side of my box will be over here at negative pi. That's where it's going to start, and it's going to end at pi. Okay, and so let's draw one of these. We have these sine curves, so if we actually, let's do, we have to do one more. So we're gonna, okay, we'll do the graph first. But we do have to do 2 cycles. I should have probably kept counting when I was doing my scale, but we'll do 1 cycle first. So with sine, it starts at the midline, ends at the midline. In the middle, it's on the midline. Halfway in the beginning, it's at the top. Halfway on the other end, it's at the bottom. And here is 1 cycle of the sine wave. Okay, now we need to keep counting. And we were counting by pi over 4, so this would be 5 pi over 4, 6 pi over 4, or 3 pi over 2, 7 pi over 4, 8 pi over 4, which would be 2 pi, 9 pi over 4, 10 pi over 4, which is 5 pi over 2, 11 pi over 4, 12 pi over 4, which is 3 pi. And that's where I stop, guys, because think about it. From pi to 3 pi, I need to go, that is a distance of 2 pi, and that's how long my sine curve needs to be. So let's continue graphing that then. Actually, the other end, if you don't want to do another box, you don't have to, but it's going to end there. So it starts at the midline, ends at the midline. I can't seem to get the right color. In the middle, it's at the midline. Halfway, it's at the top, and halfway, it's at the bottom of the box. And there's 2 cycles of the sine curve. All right, excellent. Okay, and the last one, you've almost made it. So again, example 7, we're going to state amplitude, period, frequency, phase shift, and vertical shift of this one. Goodness. Okay, so there's a lot going on here. So as we look at this, you might want to rewrite this, I don't know if it helps or not, as 1/2 times the sine of 1/4 of x minus pi over 2 minus 3. Okay, so we're not going to be intimidated by that. We're just going to do the same thing we've always done. VAP, vertical, translation, amplitude, phase shift, and period. Okay, vertical translation, it's going to be down 3. Actually, let me write that out. So it will be 3 down, drop -3. The amplitude is now 1/2. The phase shift, I'm going to take 1/4 x minus pi over 2 and set that equal to where sine originally starts. And then I'm going to take 1/4 x minus pi over 2 and set it equal to where it originally ends, 2 pi. Now again, to do phase shift, you can come up here and you can do pi over 2 divided by 1/4. That's pi over 2 times 4 over 1, which is 4 pi over 2, or 2 pi. So this is saying a phase shift of 2 pi units to the right. Now look what happens, and this always happens. When I solve 1/4 x minus pi over 2 equal to 0, this will turn out to be the same as my phase shift, because phase shift is how far we're moving from 0. So I'm going to add pi over 2. So 1/4 x plus pi over 2. How about equals pi over 2, Miss McDaniel? Okay. And then I'm going to multiply both sides by 4. And x equals 2 pi. So this is my new start. I'm not even going to start this graph until 2 pi. Okay, and then I'm going to solve the other one. I'm going to add pi over 2. And keep in mind, 2 pi is the same as 4 pi is over 2. So 1/4 of x equals 5 pi over 2. I'm going to multiply both sides by 4. And x is 20 pi over 2, or 10 pi. And this is my new finish. Instead of 2 pi, I'm going to finish at 10 pi. Wow. So let's logically look at the distance from 2 pi to 10 pi. That's 8 pi. So that should be what the formula for period gives me. So the formula for period is 2 pi over b, which is 2 pi over 1/4, which is times 4, and that's 8 pi. That's exactly what it should be. Okay, and once again, they want frequency, so quickly, just to tell them, frequency is the reciprocal of 8 pi, so that's 1 over 8 pi. Good. Okay, so I need to get all the way out to 10 pi. So I actually have this figured out. And again, when you're doing your homework and you're not sure because no one's telling you how to do this, you just have to play with it a little bit sometimes. There have been many times I labeled my axes. It really wasn't far enough. It was kind of scrunched really tight, or it just went too long and I didn't have enough room. And you just erase and you try a different scale. Okay, that's totally normal, and just expect that as you're doing these graphs. So I actually used a scale of pi over 2. You could have done pi over 4. That would have given you more room, but actually this works out really nice. So my scale of pi over 2, I'm only going to label every other, actually, I labeled every 4, but I can label every other one. So pi over 2, and there's pi, which is 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2, 6 pi over 2, 7 pi over 2, 8 pi over 2, which is 4 pi, 9 pi over 2, 10 pi over 2, which is 5 pi, 11 pi over 2, 12 pi over 2, which is 6 pi, 13 pi over 2, 14 pi over 2, 15 pi over 2, 16 pi over 2, 17 pi over 2, 18 pi over 2, 19 pi over 2, 20 pi over 2, that's 10 pi. Okay, so I am actually, now we have to think about our vertical. We are dropping this down 3, and then we are having an amplitude of 1/2. So mine is not the only correct way to do it, but I actually went every other one, I went by halves, -1, -2, and -3. And you can label these just to be consistent up above. And now we're going to make our box. So if I go 3 down, that is my new midline. So down here, that's my middle of my graph. Now I only have half as my amplitude. So since I went by halves, this is going to be the top of my graph. This is actually bugging me right here. And then the bottom of my graph will be half a unit below. So very narrow. Okay, now the left side of my box is at 2 pi. So here's the left, and the right side is at 10 pi. My goodness. So again, this is 8 pi units long. So as we draw our graph, this is the sine graph. So we know that sine starts at the midline, ends at the midline. Now the middle, the average of 2 and 10, the difference is 8, halfway would be going in 4 from each side. So if I add 4 pi's to the 2 or take 4 pi's away from the 10, I'm at, oops, didn't mean to do that, I'm at 6 pi. And then halfway between 2 pi and 6 pi, the sine function should be at 1. Well, the difference in that is 4, so go in 2 pi from each side, and I'm at 4 pi. And then halfway on the other end would be at 8 pi. So this would be one wave of my sine function. Oh gosh, and they said they wanted 2. Well, okay, so I am not going to go back and redo that. So actually, I'm going to change this to just 1 period. I'm okay with that. In class on Monday, I'll probably do it with 2, but it's again just a matter of counting and redoing. So instead of pi over 2, I would have wanted to make those a scale of pi over 4. I'm gonna have to remember to do that. But since this is the very last part of my video, I'm just gonna alter that just a little bit. All right, guys, so there are transformations for sine and cosine. Good luck.